Another letter from the THC shortcut is the T, like the thickness of the matrix. Why is it so important to talk about the thickness? You know that on the market you've got different kind of matrix. You've got the celluloid matrix, that is pretty soft kind of matrix. You've got metal matrices, but they are also different when we talk about the thickness. So there are very thick, like the 50 micron hard metal matrix from the Tor company, and on the other hand you've got the Paladin system, that is very soft kind of matrix. If the matrix is thicker, it means that it will be more stiff. If the metal matrix is thinner, it will be more soft. And what kind of matrix we should choose, whether it should be really hard or should it be soft? And in this episode you're gonna find the answer on that question. You have to remember that the thickness of the matrix is responsible for the ability to deformation. What does it mean exactly? It means that if you've got irregular shape of the cavity, it will be much easier to adapt the matrix when it's soft, and when it's very hard matrix, it will be very difficult to adapt it to the irregular shape of the cavity. So let's check what thickness we've got with a different matrix system. As you can see on this slide, you've got the metal matrix like from the Tor company, that is 35 microns, and it can be also divided into the soft and hard matrix. You've got the 50 microns with the metal Tor matrix and the BioFit blue and BioClear matrix, and we've got more than 75 microns with the BioFit and the Tor transparent matrix. So you have to remember that the thicker the matrix is, the more stiff it will be and more difficult to adapt. So not only we've got the different thickness, but often, like with the Tor company, we've got the hard and soft matrix. So you can find in the single box the 35 micron soft and hard matrix, and there will be also difference in work. So what kind of matrix should I really choose? To answer that question, we have to talk about the three things: about the ease of work, about the fire burnishing effect, and about the adaptation to cavity margin. So from my experience, it's much easier to work with the very stiff matrix that are hard. Why? Because then it's easy to push with the finger and you can be sure that it will not gonna deform. So this is the positive aspect of the work with the hard matrix. But we have to remember that there are also other aspects of it. We have also to think about the fire burnishing effect. What is it? This is the moment to explain that. We have to think about the moment when you place the matrix and there is still some space between the matrix and the adjacent tooth. So what we'll probably do? We'll probably take the ball burnisher, the ball composite applier, and we'll try to push the matrix against the adjacent tooth. And if you work with the very soft matrix, this will be probably the result. So you will deform the matrix inside. And why it's important is the fact that if you place the composite inside such kind of matrix, the surface of the composite will be very, very rough. And this is not exactly the surface that you would like to have interdentally, because as you know, this is the very difficult surface to clean. This is why we have to provide our patient with the as smooth surface interdentally as possible. This is why if you want to push the matrix against the adjacent tooth, it's much better to use or very hard metal matrix like 50 microns hard from Thor, or you can also use the celluloid matrix that are pretty difficult to deform. So you can press it very hard, but you will not break it, you will not gonna deform it. When we talk about the thickness, we have also to talk about the adaptation to the cavity margin. Why is it so important? So you have to remember that when we talk about the matrix adaptation, there are three factors that we have to think of. The first of all, we have to think about the shape factor. What is the shape factor? The shape factor is the shape of the cavity when you look at the cavity margin from the 90-degree angle. As you can see on the upper photo, the shape of the matrix it's not very similar to the sectional matrix that we will gonna choose. And if the shape of the cavity is not similar to the shape of the cavity, we will gonna talk about the negative shape factor. If the shape of the cavity is similar to the shape of the cavity, then we're gonna talk about the positive shape factor. What is also very important is the fact that you can change the negative shape factor into the positive one. And why is it so important? Because you can see that the best moment to change the shape is before rubber dam placement, because then you can easily use, for example, the abrasive stripe or the burr to open the cavity a little bit more, and you can change the shape factor from the negative to positive. Why is it so important? Because if you have a very negative shape factor, you know that the adaptation of the matrix will be very difficult, especially if you want to work on a metal hard matrix. It's almost impossible to adapt such kind of the cavities, and this is probably also your nightmare when you have to work in the furcation of the roots and you see this very negative shape of the cavity, because you know exactly that you will spend a lot of time on the matrix adaptation. This is why when you see the negative shape factor before rubber dam placement, you can use all these tools to change the shape factor from negative to positive. And as you can see, you can use the abrasive stripe, you can use the bud burrs that are used to vertical preparation also, that can give you the option to easily reduce the negative shape factor. You can also use the, for example, red or yellow torpedo burr with the active point, but using the very slow speed to open the cavity a little bit more. If you see any sharp edges on the cavity margin, you have to always reduce it, you have to always smooth it, because then the matrix adaptation will be much easier, like in this case. So you can see that this case is almost the case to the bone level, that probably it should be really difficult for the matrix adaptation. But if you think about getting the positive shape factor, then you can use very easily even the metal matrix, and this is the moment when you just press the matrix and it will adapt almost itself without any wedge. This is why it is so important to think about shape factor from the very beginning during the visit. But what should we do if we can't change the negative shape factor into the positive one? Because if you have to work in the furcation area, or you just don't have any opportunity to change the shape factor, then we're gonna have to work using the soft matrices. So the rule is pretty simple. If you've got the positive shape factor, you can use hard matrix. But if you see the negative shape factor, you always have to choose something that will be more prone to adapt, that will be more easy to adapt, like the celluloid matrix or the soft metal matrix. Look at this case. So we have to deal with very negative shape factor, like the S shape in the premolar, and matrix adaptation of the metal matrix would be very difficult. But if we use very soft matrix, like in this case this is the BioClear blue matrix, using also the irregular wedge like the wedge from the BioClear company, you can easily adapt the matrix even to the such shape of the cavity. Look at the film to see exactly what had happened here. Can we use the metal matrix when we talk about the negative shape factor? Yes, we can. Of course, there are some limits, but if you see the small negative shape factor, you can use the soft metal matrix like in this case. As you can see, I had to deal with the second premolar in this case. So after the opening of the cavity, after preparation of the caries, you can see that we've got very flat surface and there is some small concavity inside. So we'll call this situation also as a negative shape factor, but it's because it's not similar at all to the sectional matrix. For this case, I chose 35 microns metal matrix from Thor, and even that it's hard, it's still the one of the soft matrices, because you have to remember that there is only one hard matrix. This is 50 microns hard matrix from the Thor company. Any other are like some way of the soft matrices. So as you can see, using the 35 microns matrix, I was able to adapt the metal matrix very easily, even to the negative shape of the cavity. Of course, if you've got the negative shape factor, you need to use the irregular wedges, and there are a couple of them on the market. So you can use the traditional wooden wedge and you can pack the extra parts of the Teflon tape, or you can wrap the Teflon tape around the wooden wedge to get the irregular wedge, or you can use the irregular plastic wedges from, for example, from the BioClear company, or you can also use the Teflon floss technique, because this is the more universal wedge that will adapt to almost all kinds of the shape of the matrix. That was the final result that I get in this case. However, when I took the photo from the lateral side, I saw this little hole inside, and at the beginning I thought that this is probably like something like a big mistake, but after that I realized that this is the best possible shape of the matrix that I can get, because you have to remember that if you've got any negative shape factor and you've got the positive matrix, there will be some distance that matrix has to change from the negative to positive shape. And the most important thing is that you will not gonna break the matrix inside totally. So you must have like some transition space from the negative to positive, and exactly the same situation you would have with the indirect restoration. So also the dental technician would have to transform the negative into the positive shape factor. So this is not a mistake, guys. You have to remember that. To summarize that part, you have to remember that there is one hard matrix, and this is 50 microns hard matrix from the TOR company, and we've got all the other matrices that are pretty soft, like the TOR 50 micron soft, TOR 35 micron soft, BioClear Palodent, TOR transparent matrix, BioClear, and all the other matrices.